NVIDIA is not just a chip company anymore. It is the company that turned graphics hardware into the engine room of artificial intelligence. The company began in 1993 with a simple bet. Visual computing would need a different kind of processor than the one inside a normal PC. In 1999, NVIDIA helped define the GPU as a product category. At first, the obvious customer was the gamer. That gaming market mattered. It gave the company volume, developer attention, and a reason to keep pushing graphics hardware faster every generation. But the deeper idea was not pixels, it was parallel work. Thousands of small calculations happening together instead of one big calculation at a time. CUDA changed the story. Once developers could program the GPU more directly, the hardware stopped being only a graphics part. That software layer became a moat. Researchers, engineers, libraries, and tools started to build around NVIDIA hardware as the default path. Deep learning needed exactly the kind of parallel math that GPUs were good at. The old graphics machines suddenly fit the new intelligence problem. Training a modern model is not one chip doing one heroic task. It is racks of accelerators, memory, networking, software, cooling, and power working as a system. That is why NVIDIA talks about platforms. The valuable thing is the bundle: chips, systems, networking, libraries, and the developer ecosystem around them. By the first quarter of fiscal 2027, NVIDIA reported $75.2 billion from data center revenue alone. That number shows the shift. Gaming is still important, but the center of gravity moved from consumer graphics cards to industrial AI infrastructure. In the same quarter, total revenue was reported at $81.6 billion. That is not a normal chip cycle. That is a platform cycle. Blackwell is the current symbol of that cycle. Not just a faster chip, but an architecture meant for enormous model training and high-volume inference. The best way to understand NVIDIA today is the AI factory idea. Customers do not only buy parts, they build facilities that turn electricity into tokens. They pay because time matters. If a cluster trains faster, serves more users, and wastes less power per request, the hardware changes the economics of the product. The less visible piece is networking. Once thousands of accelerators work together, the links between them become almost as important as the processors themselves. That full stack position is powerful. A rival can make one chip. Matching the chip, networking, software, tools, and installed developer base is harder. That is what makes NVIDIA unusual. It sells hardware, but the buying decision often feels like a software ecosystem decision. Gaming did not disappear. It still shapes the brand, the driver stack, and the culture of performance. But now it sits beside a much larger infrastructure business. The same GPU logic also touches creators, simulation, design, and digital twins. If a workload is visual, parallel, or model-heavy, NVIDIA wants to be nearby. Robotics is another long game. Training, simulation, edge inference, and sensors all pull the company toward machines that understand the physical world. Automotive is similar. The vehicle becomes a rolling computer, and the value moves toward perception, planning, simulation, and software updates. But the story has real pressure points. Advanced chips depend on scarce manufacturing capacity, complex packaging, export rules, and massive energy demand. NVIDIA designs the key processors, but it does not manufacture them alone. The supply chain is global, specialized, and not easy to expand quickly. Export controls also matter. When advanced AI chips become strategic infrastructure, governments treat them like economic and military leverage. The other challenge comes from customers themselves. Big cloud companies want custom silicon so they can control cost, supply, and product roadmaps. That does not make NVIDIA weak. It means the prize is large enough that every serious technology company has a reason to attack part of the stack. Jensen Huang's role is part of the company identity. A founder, CEO, who kept the long GPU thesis alive before the market fully understood it. The lesson is not that one product got lucky. The lesson is that a long technical thesis can look niche for years, then become central all at once. That is why investors watch more than revenue. They watch margins, backlog, cloud spending, export limits, and whether inference demand keeps expanding. The real question is whether AI remains a build-out wave or becomes a durable computing layer like cloud, mobile, and the internet before it. Right now, NVIDIA owns the cleanest route through that layer. Accelerators, networking, software, and the trust of developers who need models to run. Over time, parts of that route may commoditize. Some workloads will move to cheaper chips. Some customers will design their own. Some demand may cool. What lasts is the architecture of the bet. Visual computing became parallel computing, and parallel computing became the workhorse of modern AI. That is the NVIDIA company story. Not just chips, not just gaming, but the platform behind the AI factory. If AI becomes the next basic layer of computing, NVIDIA is not only selling shovels, it is defining what the mine looks like.